Today's topic for our discussion is a topic from refrigeration and the most applicable topic vapor compression refrigeration system. In this system, you might have seen refrigerators in your home, and that is based on vapor compression refrigeration system. So, in this system, what happens is that you need to cool the vegetables or any material that is to be kept in refrigerator. So, first, the thing is that we should remove the heat from the substance so that it will become cool. So, the basic process is there are four process and number of basic components that are used in vapor compression refrigeration systems are also four. So in one unit one process occurs. You might have seen the Carnot cycle. So this vapor compression refrigeration system is based on reversed Carnot cycle. So what all processes are there in Carnot cycle will be there in this cycle also, but will be in opposite direction. So there are two isentropic process and one constant enthalpy process, one isentropic process and two constant pressure process. So there will be one evaporator. Evaporator will be similar to your fridge, the internal part of your fridge, where you keep the components or the vegetables to be cooled. So in evaporator is the cold space which needs to be maintained at lower temperature than the atmosphere. So here the heat will be removed from the substance. After that, the heat is absorbed by a refrigerant. That refrigerant is circulated in the cycle, and that refrigerant only removes the heat from the substance. After removing the heat, that refrigerant goes to the compressor. Here it is the compressor where we give the work input. And after the compression, that refrigerant goes to condenser where it rejects the heat to the atmosphere. You might have seen that at the back side of the refrigerator there are coils. Those coils are nothing but the condenser coil where the heat is rejected to the environment. Then after the condenser, the refrigerant goes to the expansion valve and then it expands. When it expands, the pressure is again restored back to the lower pressure. So there are two pressures. One is lower pressure on which the evaporator works, and after evaporator the pressure is increased in the compressor, and as the pressure is increased in the compressor the condenser works on the high pressure. So these are two regions, high pressure liquid and low pressure side. So these two pressures like pressure are constant in condenser as well as evaporator. You can see the process in TS cycle. The process 1 to 2 is the compression process. As you can see here, 1 to 2 is the compression process. The pressure is increased and then the at constant pressure heat is rejected to the surrounding. This is the constant pressure line and heat is rejected to the surrounding. In expansion, the enthalpy remains constant and only the pressure is reduces. So this 3 to 4 is isenthalpic process where the pressure is reduced back to the original pressure and um, enthalpy is constant. Then in evaporator, the pressure is again constant and heat is added to the system. So here you can see the heat is added to the system and pressure is constant. So this much effect will be produced because this much heat will be removed from the subject. What for whatever things you want to remove the heat. So this much heat will be removed from the subject, and so this is known as the refrigeration effect. These processes are explained here and you can see the pH diagram. So here it was TS diagram, and when we show the process in pH diagram you can see that these are the isentropic constant line. So this is 1 to 2 isentropic compression process. So then 2 say 3 is constant pressure heat rejection process, 3 to 4 isenthalpic process, H is constant, and 4 to 1 constant pressure heat addition process. So this is about the simple vapor compression cycle. And the basic components you can see: compressor, then high pressure side, the condenser, then after condenser the liquid is stored in the receiver. From there it passes to the expansion valve, and then from expansion valve it goes to the evaporator, and then again back to compressor. So this is about the simple vapor compression refrigeration system. Thank you so much.